Welcome all of you to the part 2 of the introduction. Earlier we studied some basic definitions of energy, power, electricity, electrical energy, electrical power, and discussed the classification of energy sources followed by the need for renewable energy. In today's lecture, we will cover the definition of primary energy and different forms of energy in which primary energy actually gets converted before we are able to use it, followed by some global energy scenario and Indian energy scenario with respect to the primary energy as well as the electricity. So there are 4 ways of measuring energy, but the first one, which is primary energy, let's see what does it mean. Primary energy, it is the energy in the form of electricity, transport and heating, along with inefficiencies and losses when raw materials or raw resources are actually transformed into a useful form. So basically primary energy includes all the energy of a raw resource, like from which we start secondary, tertiary, all the conversions of that energy. So the way it looks like, this picture shows when the raw material or the raw unprocessed inputs are given to the primary energy system, they have some primary energy. When they are transformed into secondary energy, which can be actually in a transportable form, there are certain losses, and those losses are called as transformation losses. When you convert raw energy or raw resources into a secondary energy, there is a transformation, and during that transformation there are different losses. For example, let's say coal. If we take coal and transfer it to a power plant and generate electricity out of that power plant, so not entire energy of coal is converted to electricity. The efficiency of that power plant may be like 50 to 60%. So only 50 to 60% of that energy would be converted to electricity. The rest of it would go in the form of flue gas or in the ash, or it can be wasted as heat. Now that secondary energy can be converted to final energy, which is actually the energy which is delivered to the customer. And when that secondary energy is transferred or converted to final energy, there are again losses while we are transmitting and distributing that secondary energy. So if when we can if there is a electricity generation, so electricity is a secondary energy, and now that electricity has to be used in our houses, that's a final energy which we need at our homes. So during that transmission and distribution also there are some losses. So this electricity from power plant, when it is delivered to the home through the transmission lines, through the distribution networks, there are certain losses again. And now this final energy is something which we are giving it to our equipment or appliances. So that energy which is used by the appliance or energy put to the desired output of the application is called as useful energy. And even in that appliance, because of its own efficiency, they will have certain losses. So when final energy is being actually used in the appliances, there will be some losses. And for example, once that electricity which is produced from coal power plant delivers to home, and if we are using that to light a light bulb, there would be some losses because of the efficiency of that bulb, and that is called as useful energy. So if you actually look at the entire scenario, from primary energy to secondary to final and useful, only a small fraction of primary energy is actually available as useful energy. And during each stage of its conversion, from primary to secondary, or secondary to final, or final to useful, there are significant losses. And based on the Sankey diagram shown here, you can make a guess that the amount of losses, they go on decreasing at each stage, and major losses come right during the transformation and transmission and distribution phases, because the final appliances, they don't have really low efficiencies, they are very efficient, but still depending on the sector and depending on the appliance, the efficiencies can vary. So this was the example of coal to power a light bulb. There are a couple of more examples. Suppose if you are using wood to provide heat, so once that wood is converted to charcoal, some energy and mass of that wood is lost as volatiles, and then that charcoal, if it is sold to market, during packaging and transportation, whether it's in the powdered form, whether it is pelletized, there would be some losses during that also. And while that charcoal is sent to a restaurant or a home for burning or for getting heat or for doing barbecue, we cannot extract 100% of its heat for the desired application. There would be some more losses. Similarly, oil to drive a car. When oil is extracted from refinery and it is converted to oil is extracted from the oil reserve, then it is converted to gasoline in the oil refinery. There would be lots of losses. When that gasoline is transported to pump, it's compressed, stored, and then filled at fuel pump, there will be some losses. And while the car uses that gasoline, again the efficiency of combustion engine in the car will have some losses. So that's how primary, secondary, final and useful energy. These are the 4 ways in which we can measure the energy. Hope that is clear, and let's move forward. So primary energy, as we saw, it includes the original, all the energy in the original raw resource, and it covers the energy required for heating, transportation, electricity, as well as inefficiencies and losses also. So if you look at global primary energy consumption source wise, most of it is obviously coming from coal, oil and gas, which are the fossil fuels. And this segment, which we had seen earlier also, for renewable energy, it is increasing since last couple of decades in order, like tremendously or exponentially. And then there is this portion of traditional biomass. So if you look at the total global primary energy consumption, it is around 183,000 terawatt hours. Okay. So what is it? Energy. Okay. Keep remembering the difference between energy and power and electricity. So this terawatt hour is the energy which is the global primary energy consumption. And as identified from this graph or the trends, clearly the fossil fuels hold a dominant share of this consumption. They are having the highest share, but renewables are rising at a higher pace compared to the fossil fuels if you look at the trends of last 2 decades. And another thing, because of the increase in population, increase in industrialization and urbanization, like lots of energy requirement, increase in buildings, the air conditioning, even lots of companies which are coming in the like software or online domain, which needs a lot of data centers, there also energy requirement is increasing. So there is a steady growth in the demand for primary energy also. So it is something which makes the world push towards finding new reserves of fossil fuels or going towards increasing the capacity of renewables. So that total energy of 180,000, if we represent it through individual fuel wise, the highest one comes out to be oil, which is around, I think, 56, followed by coal and gas. So coal is also around 45 or 46 and gas is around 42. And if you check at nuclear, hydropower, they are all around nearby 10, 7, 6, 6, and maybe biofuels are 4, 4 and 3. So if you do the addition, it will come close to 182 or 183,000 terawatt hour, the figure that we saw in the earlier. This is just showing the individual source trends over a history of last 60-70 years. And you can see like the highest fluctuation has been in oil and coal. The other renewables like the gas, the fossil fuel, the gas has been steadily increasing. Same as the scope with hydropower. The nuclear is sort of stabilized since 2000 with no new plants actually adding up to the primary energy consumption. But so far as solar and wind are concerned, solar is trying to match the capacity for wind, and The other renewables or biofuels, they are growing very gradually. So oil, gas and coal lead the competition for source of consumption. The same graph can be represented in terms of percentages, and you can see almost like 40, like almost 70% of the global primary energy is coming from fossil fuels. And if you just do the addition of percentage in the year 2024 for renewables and clean energy, it doesn't exceed 20%. So 20% of the global primary energy is coming from like renewable resources. We can even include this traditional biomass in that. So including that, it fluctuates between 19 to 21%. So it shows like we are still heavily dependent on fossil fuels for our primary energy. And primary energy doesn't just include electricity, it includes heating, transport and losses also. But that picture gives you the global energy consumption. Now if you look at per capita primary energy consumption, this indicator is important because different countries have different population, like India, China, they are one of the most populated countries in the world. And most of the developed nations, they have like significantly lower population than India and China. So, but their energy consumption would be very significant. So, if you compare those major countries or the major consumers on per capita basis, it gives you a different picture. This graph shows some of the world's top countries with respect to their energy consumption. You can see Canada and US are leading with significantly high per capita energy consumption, whereas India stands at just 10% of what is the per capita consumption in United States. So we are 1/10 of US when it comes to per capita energy consumption. And so far as the contribution from fossil fuels and renewables, this blue one stands for nuclear, because some countries like Sweden and France, they have significant primary energy coming from nuclear. And if you look at, if I change this primary energy to electricity, the contribution of this nuclear will increase further. Okay, but in India we can see a very small portion coming from renewables and nuclears, and major it's coming from fossil fuels. But with the other countries which are like relatively more developed, you can see the share of renewable is on a higher side. And so far as the world average is concerned, world average per capita is 21,000 and India's per capita is even like 3 times below the world average. So there is a huge scope for, I think, increased energy consumption in India also, in the process of becoming a developed nation just like other countries. So this was all about primary energy consumption and per capita primary energy share by country wise. Now if you look at global electricity generation, if you just focus only on electricity, obviously the primary energy, the numbers were 180,000 terawatt hour, and electricity generation, it's significantly lower than that, like only 30,000 terawatt hour is for the entire world. And if we just like divide it by the major country wise, you can see the China is the leading global electricity generator with 10,000 terawatt hour in 2025, followed by Europe, US, and then we have India, Russia, Brazil, UK and Australia. So the power generation or the electricity generation in China has surpassed all the major countries in the world in 2000 since 2012 or 2013. And that's why the investment that we talked about in the previous lecture, the investment in renewable energy as well as investment in the fossil fuel, China is the country which was leading on both the fronts. So when we look at electricity as a share or as a percentage of primary energy consumption for the world, it comes out to be around 18 to 19%. And India is just below that, like maybe standing at 17%. But if you look at China, almost 23-24% of the electricity generated is contributing to primary energy consumption, which also indicates like the cleaner or electrical use of energy for most of the applications. Now, when this electricity is generated, depending on whether it is generated from fossil fuel or renewables, or it can be a hybrid or mix of it, it will have different carbon intensity. And if you look at the life cycle carbon intensity over a period of entire life, from extraction of that raw fuel to going to the power plant and generating the electricity, we can see India has the highest life cycle carbon intensity so far as electricity is concerned. And the main reason for this is because of the dependence of India's grid on coal as a primary fuel for like the major portion of the electricity demand. And this is followed by China, Australia and the world. So even China is having the higher average life cycle carbon intensity of electricity compared to the world average. But all the other developed nations like Russia, US, Europe and UK, they have significantly low carbon intensities for their electricity generation. This is not a like significant matter of concern, considering that both India's and China's economics are evolving. But this is the point, the world average, which both the countries would try to reach while achieving their NDCs of 2050 and 2070 of a net zero target. So, life cycle carbon intensity is measured in CO2 equivalent emitted per kilowatt hour of electricity generated, and these emissions are estimated or calculated based on the life cycle, which includes the upstream, the supply chain and manufacturing stages, and it covers all the greenhouse gases. So that's the figure explaining the life cycle carbon intensity of electricity throughout the world. So that was the global energy scenario, some glimpses of what's the primary energy consumption, what's electricity generation, what's the carbon intensity, where does major countries in the world stand with respect to consumption, generation and carbon intensity. Now looking at India specifically, so per capita energy and economy indicators. This is a graph taken from World Energy Outlook, published recently, 2025, and you can see, so they actually show energy and economy indicators per capita in terms of GDP, the residential floor space which has been increasing, then the number of cars in India, the number of ACs, energy demand, coal demand and CO2 emission. These are some of the indicators which are related to energy and economy, and these numbers are on per capita basis, and we are looking at the change percentage wise. So 2015 to 24, these are based on the real data, but 2035 and 50 data are projected under the scenario of steps. So at present we have some current policies, so it's called as CPS, current policy scenario. If we look at our net zero targets, so it can be called as net zero policy scenarios, which will be more aggressive in reducing the emissions or mitigating the emissions. But there is something called as steps, which talks or which takes into account the stated policy scenario. It means we are not proposing or assuming any hypothetical policies or assumptions, but it includes the broad range of policies, the existing policies, including that those have been formally put forward but yet to be adopted, and as well as some other strategic documents which indicate the direction of transition of the country. So it's like a more realistic scenario compared to the net zero scenario. So under this scenario, we can see India has been steadily catching up with world averages on all these key energy and economic indicators, though many of those values are well below the world average. If you look at GDP, coal demand, CO2 emissions, we have all those values. When we convert it into per capita, they are well below the world averages. But in 2050, the number of ACs, the number of demand for coal, it is going to increase drastically. The CO2 emissions are not increasing drastically because of the shift towards renewables and investment in, like, say, CCUS. Recently, there was an announcement by government, like, where they put 20,000 crore rupees only for the CCUS budget. Okay, so initiatives like these show the commitment of India towards reducing CO2 emissions and still matching the increased demand for energy and transportation and residential floor space, or GDP. So if we look at the primary energy demand and consumption for India, so total energy demand, I think the unit for this is in kilotons of oil equivalent in millions. So you have seen the amount of coal. Again, these graphs are for the step scenarios. This is stated policy scenario. And if you look at till this point, till 2024, in both the graphs, so total energy demand has increased exponentially, and it is expected to steady. The supply by coal, oil and gas, it is expected to be steady compared to the supply by solar, PV and wind and biomass, which are expected to increase by higher percentages. So for example, if we look at solar, PV and wind, their energy demand increases from 2% in 2025 to nearly 20%. So they are increasing by 10 times by 2050. And if you look at the end use energy consumption, the highest energy consumption is going to be in the industry sector. Okay, the buildings and transport, it has expected to increase, but most of the energy, end use energy or primary energy, is going to be in the industry sector, because buildings, they will mainly use electricity, but in industry we will be using lot of primary energy, and there will be a lot of losses while using that primary energy in the secondary form or in the final form. So the exajoule, it means 10 to the power 18 joules. So I think the unit here which we talk about on the y-axis is in exajoules. And biomass, when we say here, it talks about the traditional use of biomass. So that was the energy, like primary energy demand and consumption for India, like where that primary energy would go in which sectors over the next 25 years. We are talking with respect to 2050 under step scenario. When the same was applied to installed power capacity and electricity generation, it is expected, like what we have at present, we have already achieved, I think, more than 50% of the renewable installed capacity. India's target was achieving 50% non-fossil power by 2030, but we achieved that 5 years earlier. And by 2035, we expect that non-fossil sources will contribute to over half of the generation under steps, because this is the installed capacity and this is the actual generation. So in actual generation, what you can see at present, the contribution by like coal and gas together is significantly higher than the clean energy sources or the renewable energy sources. So this is expected to exceed by 2035. So there is a difference between installed capacity and the actual energy generation. I think in the next lecture we are going to cover that concept of capacity factor, which is actually the ratio of these two terminologies, terawatt hour by gigawatt. So what's the capacity factor that we are running? But what we can see here, under the step scenario, like whatever policies have been put forward and are going to be implemented soon, based on that we expect that the non-fossil based power generation is going to exceed the renewable energy, going to exceed the fossil fuel based energy or power generation. At present, if you look at from the Ministry of Power's website, the installed capacity in India is around 524 gigawatt, where almost 215 and 51. So it comes out to be around 266 gigawatts, almost more than 50 or close to 50% is coming from the renewables, if I add nuclear, it can be even more, like you add at, so it will be more than 50% coming from clean and green sources, and rest is coming from the fossil fuels. So that was the installed capacity as of March 2026. If you look at the renewable power potential, the estimated renewable power potential according to different sources in India for year 2024, the data has been released by the ministry, and it says the total estimated potential is 210 gigawatt. From the previous slide, if you remember, I had done the additions, it came out to be around something close to 272 gigawatt. So 272 by 2109, it's close to 10%. So it means at present we have been able to tap only 10% of the total estimated potential of renewable power in India. So there is a long way to go. There is a huge scope to expand these renewable based installed capacity further and increase the power generation from those renewable sources. So based on the estimated potential, most of it is expected to come from wind, around 55%, and that is with the assumption of 150-meter height. So this 150, the modern turbines that we get in wind power at presently, their average height is around 100 to 160, and it is at that height we get wind at higher velocities. While calculating the wind power potential, we don't use the velocities close to the ground surface, because the velocities there won't be very high, and we don't like installed wind turbines at those small heights close to the ground. So the standard height which is taken for this potential estimation is around 150 meter, and at 150 meter wind power is expected to be 55%. Contribution of solar in this is going to be 36, followed by large hydro and other will include small hydropower, biomass power and cogeneration by gas based power. So that's the source wise estimated potential of renewable power in India. Now India has got more than 30 states and 7 or 8 union territories. So all this potential would be distributed across the country. So if you look at state wise estimated potential, mainly 4 states are going to contribute towards it, which is Rajasthan, Maharashtra, Gujarat and Karnataka. So almost 20, 30, 40, 50% is going to be contributed by these 4 states. They account for 52% of India's total renewable energy potential, which shows that the policies in these states related to renewable energy or energy is going to play a critical role in India's renewable energy future. And then there are other states like Andhra Pradesh, Jammu, which are also having enough potential of renewable power. But as we can see, almost it is scattered throughout the country, with major emphasis being focused on these northwestern or the central states in India, along with the state of Karnataka and Andhra Pradesh. So finally, since we are talking about Indian energy scenario after global energy scenario, there is like systematic governance structure so far as energy is concerned in India. And this picture or this hierarchy level image shows that. So we have Prime Minister's office at the top, and then there are 2 agencies. One is Niti Aayog, which acts as policy think tank under PMO, and they provide directions on the energy sector as well as renewable energy in India. And then there is a Department of Atomic Energy, which deals mainly with atomic energy, and because it is related to defense sector, it is also operating directly under the PMO office. But other than these 2 segments, there are 4 ministries which are directly associated with energy. 2 of them are based on fossil fuels. There is Ministry of Coal and Ministry of Petroleum and Natural Gas, and one is specifically focused on renewable energy, that is Ministry of New and Renewable Energy, also abbreviated as MNRE, which has been instrumental and responsible for implementing several schemes related to different types of renewable energy, whether it's small hydro or biomass or solar or wind. MNRE has taken lots of initiatives. And then since electricity is a major component of primary energy or the useful energy, the Ministry of Power is inherently a part which deals with the energy sector. Under each of these ministries, there are certain government agencies like which works on regulations or which sets the rules and laws related to the compliance of like equipment, compliance of ratings of the equipment, like Bureau of Energy Efficiency, Central Electricity Authority. They keep on doing audits of energy sector or energy requirement in different sectors of the country. Then in MNRE, we have NISC, NIBE, NIWE. These are all the national institutes for respective renewable energies, along with IREDA, that is Indian Renewable Energy Development Agency. Even state level, we will have these renewable energy development agencies in different states. Then in the Ministry of Petroleum and Natural Gas, we have DGs or Director Generals of Hydrocarbons, Petroleum, Natural Gas, and boards which deal with all these fossil fuels on the gas and petrol side. And then in coal, we have Coal Controller Organization. And all these agencies, they work very closely with both actually the public sector unit and the private sector unit. But since we are talking about the governance part, the public sector unit in the energy sector is more directly linked with the government agencies and ministries. So there are several PSUs working in Ministry of Power, MNRE, and natural gas as well as coal, where Coal India Limited is the biggest PSU so far as coal is concerned, and then it has got several of its sub branches. So this was all about the governance of energy, the structure in India. And if we compare India globally, where does it stand with respect to renewable energy? It stands fourth in the renewable energy installed capacity. It is fourth in the wind power capacity and fifth in solar power capacity, based on the report of 2024 by IRENA. And with that, the motivation for this or going even higher in ranking has been the NDC of net zero emissions set by 2070, as well as going for 500 gigawatt non-fossil based installed capacity by 2030. So we at present our grid is 524 gigawatt, which has around 260 to 270 gigawatt coming from renewables. So the idea or the ambition is to take this number to 500 in the next 4 or 5 years, and that's what is driving India's energy transition in a positive direction. So I think we'll stop here, and to summarize what we covered in today's lecture on energy scenarios, and before that we started with primary energy, which can be used in different forms like secondary energy, final energy, and the useful energy. And we looked at like the amount of losses which happens at each stage. And what does the primary energy constitute? It constitutes electricity, heat, transportation, inefficiencies, and losses. Then we continued with global energy scenario, where we looked mainly at primary energy consumption across the globe, source wise, fuel wise, in terms of percentage, in terms of cumulative absolute values in terawatt hours. Then we looked at the electricity generation all over the world, followed by per capita values of these numbers, where we compared major countries in the world with respect to primary energy and electricity. Then we switched on to Indian energy scenario, where we first compared the per capita values, different factors, different indicators which indicate per capita energy and economy indicators. And we observed in most of the values, we are well below the world average, with some values picking up or crossing the world average only in the steps scenario by 2050. So steps scenario is the stated policy scenarios, which includes existing policy as well as the proposed policy which are going to be adopted soon. It also includes some strategic documents which shows the governments or the countries, like what we say, motivation towards energy transition. And finally, we ended with the governance of energy in India, like how different ministries and different agencies and PSUs work in hierarchy to run this entire energy scenario of India. So with that, I'll stop here. Thank you so much.